March 1941, Mare Island Naval Shipyard, Vallejo, California. A welding torch flickered in the dim submarine construction bay as Edward Nelson, an 11-a-day welder, wrote angrily in a worn notebook. "There has to be a better way. This is madness." Navy supervisors kept telling him to work faster, yet they refused to listen to his idea. Below the wooden deck of a submarine under construction, Nelson moved through a maze of scaffolding. What he had just seen made his blood boil. A dozen workers had spent an entire shift installing just one small section of wooden deck planking. Massive scaffolding filled the compartments beneath the deck. Men stood in tight spaces with wrenches, tightening nuts onto bolts pushed down from above. Hour after hour of exhausting work just to fasten wood to steel. The method required care, patience, and time. Time America did not have as war clouds gathered over the Pacific. Yet at what would soon become one of the busiest shipyards in the world, deck installation was still done the same way it had been for decades. Theodore Edward Nelson, 36 years old and born in California, had learned mechanics the hard way. 15 years in machine shops across the state taught him how metal behaved, how electricity flowed, and how problems could be solved, if anyone would listen. What Navy supervisors did not know was that this frustrated welder had already solved their problem. And what Nelson did not yet know was that his simple, rejected idea would save the U.S. Navy more than 50 million man-hours and change shipbuilding forever. The real fight against inefficiency had been happening for weeks below deck. The date was March 15, 1941, 8 months and 22 days before Pearl Harbor. Mare Island Naval Shipyard covered 635 acres along the Napa River in Vallejo, about 25 miles northeast of San Francisco. Founded in 1854 by Commander David Glasgow Farragut, it was the first U.S. Navy base on the Pacific. By early 1941, Mare Island had become the main submarine construction yard on the West Coast. It ran non-stop, 3 shifts, 7 days a week, as tensions with Japan increased. Around 12,000 civilian workers were employed that year, a number that would grow to nearly 50,000 by 1944. One of those workers was Ted Nelson, employee number 3872. He earned $11 a day, working from 7 a.m. to 4 p.m. His job was welding submarine hulls and internal structures. He was skilled, fast, and accurate, but deeply frustrated by wasted effort everywhere he looked. The biggest problem was wooden deck installation on submarines, destroyers, and aircraft carriers. The Navy used wood for good reasons. It provided better grip when wet, reduced noise, insulated sailors from cold steel, and could be repaired faster than welded steel during combat. But the installation method was outdated, slow, and extremely labor-heavy. The process had not changed since World War I. First, holes were drilled into wooden planks at exact distances. The holes were countersunk so bolt heads would sit flush. The planks were then placed on the steel deck frame. Then came the worst part. Large scaffolding systems had to be built underneath the deck, inside cramped compartments. Multiple platforms were needed just so workers could reach the underside. Workers above pushed long bolts through the wood and steel. Workers below, standing in dark spaces barely 4 feet high, threaded nuts onto the bolts and tightened them with wrenches. Afterward, workers on top filled the holes with wooden plugs to smooth the deck. This was repeated thousands of times. A submarine deck required hundreds of square feet of planking and thousands of bolts. An aircraft carrier required tens of thousands of square feet. A single submarine deck took 12 to 16 men working 5 to 7 days. 2 days were spent building scaffolding, 1 day tearing it down, and the rest tightening bolts. Nelson had done this work many times. He had spent endless hours bent over in tight compartments, his back aching, knuckles scarred, patience gone. But his frustration was not just physical. He saw the bigger picture. War was coming. Mare Island was already behind schedule. The Navy needed submarines in the water, not sitting in dry dock waiting for decks. Nelson had been thinking about a solution for months. To him, it seemed obvious. Instead of bolting from above and tightening nuts from below, why not weld threaded studs directly to the steel deck frame? One-sided work, no scaffolding, no coordination between crews, no wasted time. Threaded stud welding already existed, only for flat horizontal surfaces. Loose flux powder was used, which fell away on vertical or overhead surfaces. Naval construction required welding in every direction. This problem had stopped engineers for 20 years. Nelson believed he had the answer. Instead of loose flux, use a small ceramic cap filled with flux attached to the stud. The flux would stay in place no matter the angle. He sketched a handheld welding gun, spring-loaded studs, an electrical trigger, and disposable ceramic caps. Each weld would take less than 1 second. One worker could install dozens of studs in the time it took to bolt just one plank. Nelson showed his idea to his supervisor, Navy Lieutenant Morrison. The meeting lasted less than 5 minutes. Morrison barely looked at the sketches. "We follow Navy procedures. Stick to your assigned work." Then Nelson approached the shipyard's chief welding engineer, a civilian named Hartwell. He explained the savings in time, labor, and cost. Hartwell listened politely, but shook his head. "Smarter men than us have tried for 20 years. If it were that easy, it would already exist. And the Navy doesn't change specifications without years of testing." "We don't have years," Nelson replied. "We need submarines now." Hartwell shrugged. "That's not my problem, Mr. Nelson. My job is to build ships according to approved specifications. Your job is to do the welding you're paid to do." Nelson left the meeting angry and discouraged. He had offered a solution that could save thousands of work hours on every submarine. It was dismissed without serious thought, not because it was wrong, but because he was just a welder. Changing procedures meant paperwork, approvals, and delays. Innovation mattered less than following rules. He made one last attempt. Nelson wrote a formal letter to the shipyard commander, Captain Thomas Withers. The letter clearly explained the waste in current methods, described the stud welding solution, and estimated the time and cost savings. He submitted it through proper channels, following all official procedures. 3 weeks later, he received a reply. It was a standard form letter thanking him for his interest in improving efficiency. It explained that all technical ideas were reviewed by the Bureau of Ships Engineering Board. His suggestion had been forwarded for consideration. The review process usually took 18 to 24 months. He would be notified if further study was approved. 18 to 24 months. By then, the war might already be over, or lost. Nelson crushed the letter and threw it in the trash. That evening, he made a decision that would change his life and naval history. If the Navy would not listen, he would build the device himself. He would prove it worked. Then they would have to listen. He cleared space in the garage behind his small Vallejo cottage. His wife, Emma, watched nervously as he collected scrap steel and welding equipment. "Ted, you're going to get yourself fired. You're supposed to work on Navy projects, not your own inventions." "This will help the Navy. They just don't know it yet." Over the next few weeks, working nights and weekends, Nelson built his first stud welding gun. It was rough but functional. A pistol grip handle, a spring-loaded plunger to hold the stud, an electrical trigger connected to a welding power source, and a quick release system to load new studs. The key breakthrough was the flux cap. Nelson tested different ceramic materials, flux mixtures, and cap shapes. After dozens of trials, he created a cap that held the flux in place, started the arc properly, and could be made cheaply. By May 1941, he had a working prototype. He tested it on scrap steel in every position, flat, vertical, overhead, and angled. It worked perfectly. Each stud welded in under 1 second. The welds were stronger than traditional bolts, and no access below the surface was needed. He brought the gun to work and showed it to fellow welders during lunch breaks. They were impressed. "This will save us so much time," one said. "You should show this to Morrison," another suggested. Nelson shook his head. "I already did. He wasn't interested." "Then quit and start your own company. Sell it to shipyards. You'll make a fortune." Nelson had never thought about that. He was a welder, not a businessman. He had no money, no factory, and no experience. But the idea made sense. If the Navy wouldn't use it, maybe private shipyards would. Shipyards up and down the West Coast were expanding. Kaiser in Richmond, Bethlehem in San Francisco. All of them faced the same pressure: build faster with fewer workers. On June 20, 1941, Nelson resigned from Mare Island Naval Shipyard. His supervisor tried to stop him. "You're a good welder. Don't throw away a steady job for some crazy invention." But Nelson was decided. "I'm going to build welding guns, and when the Navy comes back to buy them, I hope you remember this conversation." He left Mare Island with $11 in his pocket, a garage full of tools, and complete confidence in his invention. On July 1, 1941, Nelson formed the Nelson Specialty Welding Equipment Corporation. He borrowed $195,000 from the Reconstruction Finance Corporation, a government agency that supported small businesses. With that money, he rented a small workshop in Vallejo and began production. The early months were hard. He had no customers and no reputation. He visited machine shops and small fabricators, showing them the gun and explaining the savings. Most were doubtful. A few agreed to try it. Slowly, orders came in. By September 1941, Nelson had sold 18 welding guns and several thousand flux-capped studs. Then came December 7, 1941, Pearl Harbor. The attack destroyed or damaged 8 battleships, 3 cruisers, 3 destroyers, and 188 aircraft. Over 2,400 Americans were killed. The United States was now at war. Shipbuilding became a matter of survival. Yards went into overdrive. Kaiser began mass-producing Liberty ships. Mare Island received emergency submarine orders. Bethlehem Steel and others ran triple shifts. And every shipyard faced the same question: how to build faster. Nelson's phone started ringing. Buyers who had ignored him weeks earlier now wanted large orders. Kaiser ordered 50 welding guns and 10,000 studs. Bethlehem Steel ordered 40 guns. Even Mare Island placed an order: 60 guns and 20,000 studs. The purchase request was handled by Morrison. There was no apology, just a formal order and a request for fast delivery. By January 1942, Nelson's small shop couldn't keep up. Orders poured in faster than he could build. He moved to a larger factory in San Leandro. It sat alone in a cornfield, but it had space and power. By March, he employed 20 workers. By June, 50. By September, 150. The factory ran non-stop. 30 welding guns rolled out each day. Stud production reached thousands daily. Every major West Coast shipyard now used Nelson's equipment. The results were dramatic. A submarine deck that once needed 12 workers and 6 days could now be installed by 3 workers in 1 day. Scaffolding was eliminated, welds were stronger, decks were easier to repair. Submarine production at Mare Island sped up sharply. Stud welding soon spread beyond decks to pipe supports, cable mounts, equipment brackets, and bulkheads. What had been ignored for years became essential overnight. The Navy, which had once ignored Nelson's proposal, now studied his process closely. Engineering teams tested weld strength, durability, and failure points. The results confirmed what Nelson had known all along. His welds were not only faster than bolts, they were stronger and more reliable. On November 19, 1942, just 11 months after leaving his $11 a day welding job, Ted Nelson received an unexpected visit. A group of 5 Navy officers arrived at his San Leandro factory without notice. They wore full-dress uniforms. Captain Harrison, representing the Bureau of Ships, spoke for the group. "Mr. Nelson," he said, "the Navy has completed its evaluation of your stud welding process. We have determined that your invention has saved the United States Navy an estimated 5 million man-hours in submarine and surface ship construction over the past 10 months. That number will increase as more shipyards adopt this technology." He paused, then continued. "On behalf of the Secretary of the Navy and the United States government, I am authorized to present you with a citation for exceptional contribution to the war effort." Nelson was stunned. His idea had been dismissed, his proposals ignored. He had been forced to quit his job and risk everything to prove it worked. And now the Navy was honoring him. Captain Harrison noticed the mixed emotions on Nelson's face. "I understand you submitted a proposal to Mare Island in early 1941, he said. "I reviewed that file. Your idea was not properly evaluated at the time. That was a mistake, and I apologize on behalf of the Navy." He added, "Your decision to develop the technology on your own allowed it to be deployed faster than the normal approval process would have allowed. Sometimes the best way to serve your country is simply to solve the problem." Nelson accepted the citation with pride, but also frustration. Pride in what he had accomplished, and frustration that bureaucracy had nearly stopped it. The war continued, and demand only increased. In March 1943, Nelson opened a second factory in Camden, New Jersey, to supply East Coast shipyards in New York, Philadelphia, Norfolk, and Charleston. By mid-1943, his company employed more than 400 workers and earned about $4 million a year. Nelson still worked 16 hours a day. He wore the same shop clothes as his employees and paid himself only $1,000 a month. All profits went back into expansion, equipment, and paying off loans. The Navy's early estimate of 5 million man-hours saved was only the beginning. As stud welding became standard across naval construction, the savings multiplied rapidly. By 1943, stud welding was used on aircraft carriers, battleships, cruisers, destroyers, and hundreds of smaller ships. Essex-class aircraft carriers used about 20,000 studs each. The Navy built 24 of them during the war. Iowa-class battleships used stud welding for decks, equipment mounts, and armor. Baltimore-class cruisers and countless other vessels relied on it as well. The biggest impact came in submarine construction. Mare Island, where Nelson's idea had been rejected, became one of the most efficient submarine yards in the world. It built 17 submarines during the war with steadily decreasing construction times. Portsmouth Naval Shipyard in New Hampshire became the top submarine builder. Between 1940 and 1945, it completed 79 submarines. Stud welding played a major role. Portsmouth used it throughout the submarines, not just on decks. On January 27, 1944, Portsmouth launched 4 submarines in a single day: Redfish, ronquil, razorback, and scabbardfish. No shipyard before or since has matched that achievement. In 1944 alone, Portsmouth completed 32 submarines, about one every 11 days. Across all shipyards, the United States built 203 submarines during World War II. Each one used thousands of studs. Each stud saved minutes of labor. Multiplied across hundreds of submarines, the time savings were enormous. And submarines were only part of the story. The Liberty Ship program produced 2,710 cargo ships. Each required between 5,000 and 8,000 stud-welded attachments. At peak production in 1943, American shipyards launched 3 ships per day, 75 per month, 900 per year. This pace was only possible because of new construction methods, prefabrication, modular assembly, specialized tools, and faster attachment systems. Stud welding was one critical part of that revolution. By spring 1943, the Navy formally recognized Nelson's contribution. On May 11, 1943, the Secretary of the Navy awarded the Nelson Specialty Welding Equipment Corporation the Army-Navy E Award for exceptional in production. Only about 5% of war contractors received this honor. The ceremony was held at the San Leandro plant with full military honors. Every employee received a pin. The factory flew the award pennant. The company later earned 2 additional stars for continued excellence. Standing before his workers in his usual shop clothes, Ted Nelson spoke briefly. "We didn't do this for awards. We did it because our country needed it. Every stud we make helps bring our sailors and soldiers home safely. That's all the reward we need." By the end of the war, the Navy estimated that Nelson's invention had saved more than 50 million man-hours in ship construction. 50 million hours. That is the equivalent of nearly 5,700 years of human labor. If one person worked 8 hours a day every single day, it would take more than 19,000 years to reach 50 million hours. All of that time was saved by one simple idea: a spring-loaded welding gun and a ceramic flux cap. That saved time meant ships reached the water faster. More submarines hunted Japanese supply ships. More destroyers escorted convoys. More aircraft carriers launched airstrikes. More landing ships carried Marines onto hostile beaches. Every ship completed sooner meant more fighting power, more supplies delivered, and more lives saved. The strategic impact was impossible to measure. Nelson's invention also brought an unexpected advantage. Stud welding required less skill than traditional bolting or welding. New workers could learn it quickly and use it safely. This became critical as the war went on and labor shortages grew. Women entered shipyards in record numbers. Rosie the Riveter became the symbol, but there were also women welders. They operated stud welding guns, installed decks, and mounted equipment. Many became highly skilled. At its peak, Mare Island Naval Shipyard employed nearly 50,000 workers, including about 9,000 women. Kaiser shipyards employed hundreds of thousands, with women making up nearly 30% of the workforce. These workers needed tools that were fast to learn and safe to use. Stud welding was a perfect fit. By 1944, the war had clearly turned in favor of the Allies. American factories outproduced Germany and Japan combined. The arsenal of democracy ran at full power. Nelson's welding guns were only a small part of this massive effort, but small improvements matter. In war, efficiency saves lives. Faster shipbuilding meant more naval power deployed sooner.
More naval power meant more enemy ships sunk, more islands captured, and greater pressure on Japan. The submarine campaign proved this. American submarines sank over 1,000 Japanese merchant ships, totaling about 5 million tons, along with an aircraft carrier, 8 battleships, and many cruisers and destroyers. This success was possible because America built submarines faster than Japan could destroy them. Japan began the war with more submarines, but built only 126 during the conflict. The United States built 203. Every month of faster construction mattered. Every week a submarine reached the fleet sooner meant another week attacking enemy shipping. Aircraft carriers showed the same pattern. In December 1941, the U.S. Navy had 7 carriers. By August 1945, it had 99 of all types. The Essex-class carriers formed the backbone of this force. 24 were built, each carrying up to 90 aircraft. From mid-1943 onward, these carriers dominated the Pacific. They bombarded enemy positions, launched airstrikes, protected landings, and defeated Japanese naval forces. At the Battle of the Philippine Sea in June 1944, American pilots destroyed over 600 Japanese aircraft in what became known as the Great Marianas Turkey Shoot. This victory happened because America had more carriers, ready sooner. The D-Day invasion on June 6, 1944, required about 7,000 ships and landing craft, the largest amphibious assault in history. This was possible only because Allied shipyards produced landing craft by the thousands. These landing ships were simple, flat-bottomed vessels designed to run onto beaches. They needed to be built fast and fitted securely. Stud welding was ideal. Ramps, deck fittings, and mounts could be attached quickly and reliably. A technology created for submarines now supported the largest invasion ever launched. After Germany surrendered in May 1945, attention turned fully to Japan. The planned invasion, Operation Downfall, was set for November. Shipyards prepared for another surge in production. Then everything changed. On August 6 and 9, 1945, atomic bombs destroyed Hiroshima and Nagasaki. Japan surrendered. World War II ended on August 15. The war production machine slowed almost overnight. Contracts were canceled, workers were laid off, shipyards closed or shifted to civilian work. Nelson's company faced an uncertain future as military orders vanished. But Ted Nelson had planned ahead. During the war, he had already considered peacetime uses for stud welding. The method was not limited to ships. Any industry working with steel could use it. Construction, bridges, buildings, vehicles, pressure vessels. Nelson shifted to civilian markets. He sold stud welding systems to builders, fabricators, and manufacturers. The post-war building boom created huge demand. Highways, bridges, factories, and homes all required steel connections. By 1948, his company had successfully transitioned to peacetime production. It was smaller than during the war, but stable and growing. New stud designs and improved equipment followed. In 1950, Nelson sold the company to TRW. The sale gave him financial security, but his name stayed on the products. Over the years, the company changed owners several times, but the Nelson brand survived. Today, Nelson stud welding systems are still made and sold worldwide. Modern systems are more advanced. Power supplies are precise. Automated and robotic systems handle high-volume production. But the core idea remains the same. A stud, a flux cap, a spring-loaded gun, and a 1-second weld. No scaffolding required. Stud welding is now used in skyscrapers, bridges, power plants, and automobiles. A solution created for wartime shipbuilding is now part of everyday construction around the world. Perhaps the most fitting legacy appears in ship restoration. The battleship Texas, one of the few remaining ships that served in both world wars, is undergoing restoration today. Workers are using modern Nelson stud welding equipment to repair its structure, using the same principle Ted Nelson invented more than 80 years ago. A simple idea, born in a garage, still holding history together.
The same is true for the submarine USS Pampanito, a World War II submarine now preserved in San Francisco. It sits at the Embarcadero and welcomes more than 100,000 visitors each year. Keeping an 80-year-old submarine safe and operational requires constant maintenance. Nelson's stud welding equipment allows volunteer crews to do repairs efficiently without needing highly certified welders for every task. Ted Nelson lived long enough to see his invention reach far beyond what he imagined in 1941 when he first sketched his idea in a notebook. He watched stud welding become standard practice in shipbuilding. He saw it adopted by industries around the world. He saw his name become permanently linked to a welding process. Nelson died in 1994 at the age of 89. He lived long enough to see the end of the Cold War and the transformation of the world his generation had fought to protect. The numbers only tell part of his story. 50 million man-hours saved, 2 Army-Navy E awards, thousands of ships built faster, billions of studs manufactured. But numbers cannot show the real impact. Behind those statistics were sailors who returned home because their submarine was completed in time, Marines who survived because landing craft were ready when needed, families who were spared loss because the war ended sooner. The true value of innovation is not speed or efficiency alone, it is lives preserved. Ted Nelson, an $11-a-day welder told his idea would never work, saved more lives than many combat heroes. He did it not with weapons, but with welding, not through destruction, but through construction. His rejection was not unique. History is full of innovators dismissed by experts. The Wright brothers were told powered flight was impossible. Henry Ford was mocked for mass-producing cars. Chester Carlson struggled for years before xerography was accepted. What made Nelson different was his response to rejection. He did not argue endlessly with officials. He did not beg skeptics for approval. He quit his job, risked everything, and proved his idea worked. Once it did, the market spoke for him. This is the heart of innovation, not waiting for permission, not accepting that things must be done the way they always have been, seeing a problem, building a solution, and having the courage to act, even when institutions resist. Mare Island Naval Shipyard, where Nelson worked and where his idea was rejected, closed in 1996 after 142 years of service. It built 512 ships and repaired thousands more, including 44 submarines. Today, the site is being redeveloped, though many historic buildings remain. Visitors walking through the preserved dry docks and workshops can imagine the wartime rush when tens of thousands worked around the clock. In one former shop, now a small museum, there are tools and photographs, but no display dedicated to Ted Nelson, no monument to the welder who saved 50 million man-hours. That likely would not have bothered him. Nelson did not seek fame. He wanted things to work better. That was reward enough. But his story carries an important lesson. Innovation often comes from unexpected places, not from experts, but from people doing the work every day, not from research labs, but from garages and workshops, not from official channels, but from those willing to risk failure to prove an idea right. The next great innovation may come from a welder, a mechanic, a nurse, or a teacher. It may come from someone told to follow procedure or warned they are wasting time. History suggests we should listen to them. Ted Nelson's invention was simple: a ceramic flux cap and a spring-loaded welding gun. Together, they eliminated scaffolding, improved safety, increased strength, and saved time when time mattered most. 50 million hours, nearly 5,700 years of human labor. And that number does not include the strategic impact: ships deployed sooner, battles fought with greater strength, lives saved because production moved faster than the enemy expected. America won World War II not only through bravery, but through production. Soldiers fought the battles, but workers and innovators made victory possible. People like Ted Nelson, who refused to accept inefficiency when a better way existed. That lesson still matters today. The challenges we face, energy, infrastructure, climate, resources, will not be solved only by experts and institutions. Solutions will come from people who see problems clearly and fix them practically. Ted Nelson began as an $11-a-day welder. He became a millionaire industrialist whose invention helped win a war, but he never forgot who he was. When asked about his success, he would shrug and say, "I just made a better mousetrap. The world came to me." It wasn't genius, it was common sense, applied with courage at the right moment. That is Ted Nelson's legacy. Not awards or numbers, but proof that one person with a good idea and the will to act can change history. Every time a welder pulls the trigger on a stud welding gun, that legacy lives on. And somewhere, right now, someone is sketching an idea everyone says won't work. They might be wrong.